Good afternoon, everybody. Thank you for joining our today's webinar on occupational hygiene, and a big thank you to Jason Hodgkiss, British Occupational Hygiene Society Honorary Treasurer and a specialist member of the Faculty of Occupational Hygiene and Managing Director on Advice Limited. Before this webinar, we had an informal chat about who's going to be attending this webinar: nurses, doctors, hygienists, technicians. And it reminded me of my first exposure to occupational medicine, which was through occupational hygiene, basically. About 30 years ago, I was really impressed when I noticed occupational health department in a chemical factory was measuring the level of metabolites in the body to find out the level of exposure of employees during the shift. And that was the first thing which really impressed me and attracted me to the world of occupational medicine. Years have gone, and now I know that some of our colleagues in the world of occupational hygiene have gone to the gene level, and they just look at the, say, lifelong exposure to chemicals through, assessing the gene to find out what's going on in terms of exposure. And things are totally different at the moment. And we are absolutely lucky to have Jason with us today to speak with us about important topic of asbestos and silica and occupational hygiene aspects of that. Over to you, Jason. Thanks.
Thank you, Kaba. Yeah, that's pretty much covered it for me. The only other thing to say is I'm in my 34th year of doing occupational hygiene now. Sort of started bank holiday, August bank holiday 1989, just after the August bank holiday. So anyway, that's me. I've done a number of jobs, but occupational hygiene pretty much is the crux of what I've done, down to sort of directing companies doing the same thing. So yeah, today we're covering occupational hygiene at work. I didn't know the audience, so you have to forgive me if I sort of dumbed it down too much, or if I've not made it technical enough. We can cover that in the answers at the end. So if you've got any answers as you go along, you can type them into the chat box, and then we'll answer them at the end. That's okay. Thank you. So I'm here representing British Occupational Hygiene Society, really, rather than my own company. It's only sort of a cheeky ad campaign that I've got my own T-shirt on. But I'm the honorary treasurer of British Occupational Hygiene Society. So we're the leading authority in work health protection. We're going for 70 years. It's a science-based charitable body providing expertise and guidance and recognition and control. Started in 1953, so we're coming up to our 71st year. And we've got 1,400 members represented in 45 different countries. The only occupational hygiene organisation to be awarded a Royal Charter, which allows us to offer a charter status to occupational hygienists to fulfil the brief. Sorry if I'm talking too fast. Also, I've caused myself a bit of a problem because I listen to podcasts, but because they talk quite slow all the time, I sort of listen to them time and a half. So, Nick, if you want to jump in if I'm going too fast. So, with the definitive voice of occupational hygiene in the UK, we've been providing international leadership on protection against asbestos since the 1960s, coming up with lots of the codes of practices that the HC use, and a lot of the HC guidance directs people towards the British Occupational Hygiene Society for guidance when they're looking for competence. And in 1971, we also did the standard for sound level meter exposures. Our mission is to safeguard the UK's current and future health through effective management of the workplace. And our vision is a country where work is not a cause of acute or chronic ill health. So our keynote speaker a couple of years ago, a conference, was an oncologist, and he did a fantastic half an hour of how he dealt with occupational cancers. But his closing statement was that if occupational hygienists do their job well, then that sort of reduces the amount of work he has to do because he won't be seeing the occupational cancers. This infographic is something that sort of stayed with me since I first saw it probably about 8 years ago now, which is it is that sort of, everybody's heard that we whisper health while we're shouting safety, and this is the graphic that sort of brings that home. So these are figures from HC figures from 2016-17, which shows you that 99% of people who died from work-related causes, 99% of those 13,000 died work-related causes in that year, and only 1%. Every death is a tragedy, but 144 workers died in the same year from accidents. So again, it's something because it's sort of like death by 1,000 cuts, because we can't see the damage happening. People sort of brush it under the carpet. So our aim is to work to eliminate harmful exposures, promote safe and effective substitutes, design out threats to human health, manage work practices that places of people at risk, and ensure that people in working environments have the right protection at the right time. What we do, we also promote the science and the practice of occupational hygiene. We've got members, said it, 1,400 members. They range from sort of just individual members, but then if you do the training, if you do training, go get qualified, then you can join the faculty of occupational hygiene and also the faculty of asbestos management. We also have campaigns. They also have to run campaigns and conferences. So our two main campaigns we've done recently and well received has been Breathe Freely, both sort of lung health issues, really. Breathe Freely in construction and Breathe Freely in manufacturing. Conferences and events. We run numerous conferences throughout the year, so on the next slide. And then we publish a journal, the Annals of Occupational Hygiene, where sort of peer-reviewed journal or peer-reviewed studies get published. And then we help take policy, produce policy and technical guidance for government regulators, etc. So our conferences, this year we've got the IOA, that's the International Occupational Hygiene Association's conference. So that sort of comes around every fourth year, and BOHS help out on that one. So this one we've got 500 attendees this year, and it's happening in Dublin. In September we've got LEV conference, hopefully have 120 attendees, and so on and so forth. But down to workplace health inequalities, which we're working with the Society of Occupational Medicine and Council for Work Health Work and Health promoting and contributing to content. Then next year we should be back to our normal regular about 350 attendees to the British Occupational Hygiene conference, which will be in next year in Newcastle. So occupational hygiene is the science of work health protection. So we'll cover what the Venn diagram in a minute of how occupational hygiene sort of overlaps with occupational health. And our occupational hygiene is identify, assess, and control the risk of health hazards that arise from the workplace. And they aim to increase the health and understanding in the working environment. So a lot of what we do is try to do is education and get people educated to the risks. Occupational hygiene is a term for managing the effects on the workplace, and occupational health assist with the Venn diagram coming up, assist in delivering, you know what we do with occupational health providers, assist in health surveillance and rehabilitation, etc. There's the Venn diagram. So we're protecting people, and then you're managing the health of workers, and the well-being speaks for itself. This infographic again, this sort of explains it a bit better. So you've got the work activity, which produce an exposure to harmful substance, and then this is where the occupational hygiene comes. So we aim to be preventative, so people don't go on to get the disease. A lot of the time when we're doing health assurance or health monitoring, by the time you're seeing at your end, by the time you're seeing noise-induced hearing loss or something like that, the damage is already being done there. So we aim to try and stop that from happening. Well, we're here to talk about occupational diseases, and then asbestos and silica. So I will drill down onto asbestos and silica just talk a little bit about the other diseases. So we do have silicosis from silica, lung cancers, but that can be from silica, welding fume, diesel exhaust emissions, asbestos obviously, but also wood dust. We've got COPDs, again, that's caused from the silica and wood dust really. Asbestos cancers, so everybody's heard of mesothelioma, which is a cancer of the lining of the cavity, the lung cavity. Asbestos causes lung cancer. That was a while before we worked that one out, mainly because of the other confounding factors such as smoking, and laryngeal and ovarian cancers. And then it's not as clear cut. There is studies coming out now that are linking asbestos, so epidemiological studies coming out now that are linking asbestos to colorectal cancers, breast cancers, pharyngeal, esophageal, gastrointestinal leukemias, prostate. Well, the prostate is sort of really in the really early stages of study. And then we've got obviously occupational diseases, asthma, that's from welding for welders, and wood dust and two-pack coatings. From the asbestos, we do have a legacy asbestos, which we'll talk about later, but yeah, this is again a diagram. It's reproduced in a HC document. Just you're not supposed to be able to read all of that, but it just tells you whereabouts asbestos can be found in buildings, so it's pretty much used everywhere. Silica, again, this is primarily in the construction industry, so we'll talk about that in a moment. Then we've got wood dust. We'll also talk about sort of the controls, engineering controls that we can put in place, but we've got wood dust. If it's hard wood dust, then it's carcinogen, but equally in sort of a lot of woods and prepared woods and plywoods, etc. You've got the glues in there and the antifungals and the fire retardants chemicals that are also in wood dust. You see this guy is protecting his hearing, but he's not protecting his lungs. And then welding fume. So yeah, that can cause manganism or asthmas and occupational cancers. So as stated, talk about silica for a moment. So thing you'll hear is RCS, which is respirable crystalline silica. It's pretty much as we describe it as occupational hygiene. It's an age-old problem, but it's sort of you'd hope we didn't see things like this anymore, but we still do see things like this where they're producing vast amounts of silica dust using disc grinders, cutters, etc. But it is at both ends of the construction industry, so it's in the installation, but also in the decommissioning of structures, etc. So silicosis, how much silica is there in the working environment is an example, down to sort of the latest the studies that are happening at the moment. The studies that are happening at the moment about artificial stone and people fitting kitchen worktops. Because it's such a high level of silica, up to 95%. They are the sort of the target audience at the moment for our efforts. So silica dust comes, as you'd expect, comes in all different sizes, but we're particularly concerned about the respirable silica because that once it gets into your lungs, and again, went to a presentation once where they said silica is in bricks and your houses are built of bricks, and how long do your houses last? So the silica in the bricks, once it gets into your lungs and past your body's natural defences, it's very difficult to remove, and that's when you get a scarring of the lung and you get silicosis. So silicosis, again, as I say, is from the respirable dust. This is a graphic for, if that's the width of a human hair, which is about 0.5 millimetre. You've got inhalable dust, which is the 10 microns, and then every time I touch my magic Apple mouse, it does that. The inhalable dust is 10 microns, and respirable is anything less than 2.5 microns. To give you a better picture of that, it's a scan electron micrograph. So you can see the width of the human hair there, facial hair, and you can see the sort of size particles that we're trying to arrest before they get into our lungs. Again, another interesting fact is a lot of the silica that we've got on the Earth is sort of been eroded, sort of rounded off. So the silica that's on the Moon has not had that sort of weather erosion and is a lot sharper than what's seen here. This is quite a difficult thing to understand. So we've got occupational workplace exposure limits, and the exposure limit for respirable crystalline silica is 0.1 milligram per meter cube measured over an 8-hour period. So I'm proposing that this dust, the silica dust here in this picture, is that it's only the respirable fraction that people are exposing today. And again, it doesn't say how much force is putting that together, but we're just going to use static forces to put that together. But that's the amount of silica that somebody's allowed to be exposed to in a day before they're reaching the occupational exposure limits. This is a diagram we use for telling people is that things aren't always as they seem. So if you take that photo under normal light, there's exactly the same activity happening a second later, but under a Tyndall beam, and you can see the particulates in the air refracting the light. So even though it might look not look like a dusty process, it can be. So the way we deal with the risks is pretty much the same as the hierarchy of controls that we're all used to, really, which is the elimination, prevention, engineering, working our way down to PPE being the last line of defence. So elimination, we can design this out. The two photographs on the left, obviously that's the top photo on the left. There's a drainage channel there, which has meant that every single tile has had to be cut to fit that drainage channel. If they'd moved the drainage channel 6 inches to the left, then they wouldn't have had to make all those cuts along the whole length of there. And again, I think the one on the bottom is it's just aesthetics. So of course, lots of bricks to be cut there just for aesthetics, unless that part of the payment was failing. But the picture on the right is the way to do it, and that is the London School of Economics Sawswee Hock building in London, and that's constructed with 46 varieties of standard brick shapes, but then also 127 specifically designed shaped bricks, and then about from 175,000 bricks that have been used to build that building, none of them had to be cut. They were all cut as obviously cut as wet clay, but then they were all cut as wet clay and then kilned, and then there was no cutting and releasing silica to build that building. We can substitute. So again, we can use obviously silica coming off of what they're cleaning, but yeah, we can use another mineral called olivine, which is abundant in the Earth's crust, but it's not as harmful as silica or sandblasting. LEVs are good in certain situations, such as factories where you can set up workstations and you can put have the LEVs on these sort of extending arms and put it next to the workplace, where you can put it onto conveyors, and that extracts a lot of the dust and takes it off and puts it into hoppers, etc., where it can be dealt with prior to being in the atmosphere and as breathing in. Again, we're not talking too much about welding, but it's a good example of LEV, again, being in a factory. And a good example on the right of LEV not being pretty much applicable, because it's difficult to get LEV on a mobile work platform. That was about 40 feet up in the air, welding some steels. LEV has to be tested, should be every 18 months, and obviously positioned right. There's a couple of things wrong with this photograph. The LEV is drawing dust past the operative, so even if it was working properly, which it doesn't look like it does, look like it is because of the dust in the environment, it would be still drawing the dust. It should be drawing the dust away from the operative. This whole process should be wet down anyway, but then the LEV probably not been tested and probably not working efficiently. more engineering controls, and that's just capture at source. So you've got on-tool extraction. That's for drilling, and it's just a vacuum straight onto a wood saw, circular saw. You've got water suppression. There's the picture we saw earlier with the no water suppression. It's amazing how much water can suppress the dust coming off there, and that's basically just water sprayed straight onto that spinning disc because it's cutting the concrete. And then you've got a mist. This is a demolition site, and that's a mister. So the fine particles of water capture and take out of the air the fine dust particles. Do cause another issue there because that just drifts down to the floor under gravity, and then causes another issue where we could have controlled it from being lifted from the floor or what. Other engineering controls are using a vacuum instead of dry sweeping. Some of the monitoring occupational hygienists have done in the past found that people got a great deal of their daily exposure at the end of the day when they're doing the cleanup process. So you got there, the vacuuming is obviously a lot cleaner than brushing. And so there was a campaign that BOHS ran, which was for ban the broom, and it was adopted by a lot of people, but there's still a lot of people, they can't see an alternative, so they're always using brooms on site. This is an example of that in the front. So they were working from the left to the right, so the process is getting cleaner as they move along. They're laying steels there from the left, and you can see there's a vacuum there once we get the sheeting down. But you can still see the two guys in the background. It's down here, two guys in the background, still brushing up cement and not wearing respirators. And then we've got administrative roles such as training, risk assessment method statements, briefings and daily work briefings, schedules, etc. And then PPE, the reason it's a last resort is because then everybody knows this already. So I say I'm sort of preaching downwards, I apologise, but yeah, RPE is the last line because it relies on people to use it properly. And it to be fitted properly, and multitude of other reasons why PPE should be the last line of defence. This photograph was taken February this year, so you can see we've still got a lot of work to do. There's a lot to be said about these photos, really. So the one on the left, that's not proper storage of RPE. Again, we start relying on the individuals on site to be looking after their own health. There's lots of reasons why it doesn't happen: bravado, macho culture, that sort of thing. But yeah, they're hanging a respirator in a dusty environment to pick up dust on the inside before you put it on and start breathing in that dust is an issue. This guy on the right, everybody should have a face fit test for respirators, respirable protective equipment, respiratory protective equipment. Everybody should have a face fit test. So, and this gentleman I know is, because I spoke to him, is that he's a Sikh, so he's always had a beard. I don't know who face fitted him or who issued him that PPE, but it was the wrong PPE. As we discussed earlier, he's got a beard, so the beard holding the seal away from his face is allowing all the silica dust to just go in through the edges. People will be pleased to know that after I took that photo and caused a bit of a stink, this was the same guy a couple of weeks later with a full positive pressured as well. So positive pressured. So it's filtered on the back. There's a filter pack on his back there, and it's blowing clean air into the mask, which is then blowing any sort of dust out away from his breathing zone. These are the options that we've got for people with beards, people with turbans, number 3, and then for welders, again, positive pressure. So it's relying on a sort of battery pack and positive pressure to feed into the mask, meaning that there's no ingress of air coming through into the mask apart from that that's filtered. And then you've got these assigned protection factors as well. So that's how much it will reduce the exposure by. Into the end of the silica now. So this is sort of the sciencey bits really, but we've got our workplace exposure limits, not always corrected to a 8-hour time weighted average. So we know that we're standardizing things. So someone might do a 10-hour shift, but we'll correct that back to an 8-hour shift. You've got the 3 lines here is total inhalable, total respirable, and respirable crystalline silica. And this is the exposure versus the control limit on the end here, on the last column. You'll see that even though some of these are below the control limit, below the workplace exposure limit, they were still marked as yellow because we're not monitoring everybody. And this means that sort of we've got similarly exposed groups. Again, a little bit sciencey, but it's down to sort of geometric means. We're not on a sort of standard bell curve. And to say that everybody is safe all of the time, we expect we'd like the results to be less than 10% of the workplace exposure. Okay, asbestos. This is more down where I'm a specialist member of the Faculty of Occupational Hygiene. That's my specialism in asbestos. So here we go. How are we doing for time? Oh, I've only got 15 minutes left. So I'll just sort of race through these. So what is asbestos? Naturally occurring mineral. The 6 types are legislated for, pretty much commercially used in the UK. So we've got Crystalline, Amosite, and Crystalline, which are white, brown, and blue respectively, and then lesser used, but tremolite, actinolite, and actinolite. The first 5 are amphibold fibres, which mean they're sort of straight and needle-like and split along their length and become finer and finer. And the last one, the Crystalline, the first one, the bottom 5 are amphibold, and the first one is serpentine, which meant it had a sort of slightly less hazardous than the amphibold fibres. It's curly, less aerodynamic, less needle-like. So it was mined. Again, it's naturally occurring mineral like the silica. It's mined in South Africa. In these countries, it's not anymore in Australia, Canada. And it was never commercially mined in the UK, although there were some seams of asbestos in the tin mines in Cornwall. These are just some historical pictures, which is quite sad because the young people, young kids, in the sorting rooms, and women there. It must have been quite a hard job. They've got hammers there, they're just crushing it down to fibres, and then it's getting to more and more dusty processes. Probably came down by gravity through the floor, and guys there bagging it up. We're a lot better than we are now. We're a lot better than that nowadays. So why was it used? It's thermally resistant, fire resistant, chemically resistant. It was strong, flexible, and it was cheap, which is not a reason why it was used, but there was no barrier to using it because it was so cheap to produce. The thermally resistant is for both from heating pipes, but equally was sprayed to the bottom of car parks to stop cold going through the floor to the offices above. Fire protection. This is probably the worst bit of asbestos I ever found, which is it's sprayed onto steel beams, and you can see it's in a very good condition. It's not very well sealed, but it was this situation. It was at the underside. This is the bottom of the side of the seating area for a cinema, and this was used as a plenum chamber to bring in the air and sort of to get up to temperature before they blew it around the theatre. So. Typical uses for lagging the pipes, spray coatings, and this is going from sort of pretty much from, apart from the Artex, it's going sort of from worst to least case really of hazard. Insulating boards, cement sheets, composite things such as toilet cisterns, ropes, gaskets, floor tiles. Again, apart from the sort of links that are now being given for sort of esophageal and gastrointestinal cancers, bladder cancers. we're normally looking at the respirable issues, and they were the first ones that were recognised. So the risks were through inhalation of fibres. Again, we'll go on to how much we've got in the country in a minute, but we've got far too much to remove. There's been questions in Parliament recently of how if we could remove all asbestos from all buildings, at least all hospitals and schools, by 2050, and that doesn't seem like it's an achievable task with the infrastructure we've got at the moment. So we manage it in situ, and pretty much it's only when it's damaged that the fibres become released, and that becomes an issue for health reasons. Diseases, as we discussed earlier, asbestosis, which is a scarring of the lung tissue, mesothelioma, lung cancers, and pleural thickenings, although they're not as bad as the first three. As I said, the risk of disease is associated with inhalation of fibres. Therefore, if the material is intact, then we've not got any fibres to be worried about. And unless it's, if it's a loose bound, and they call it friable, then the fibres can be released more readily. One of the reasons it took us so long to find out, although again, just quickly, it was sort of the late 1800s, lady factory inspector recognised there was a lot of people associated with asbestos factories who were having respiratory problems. And that was a long while before we started dealing with it. Sorry. Oh, maybe that picture's going to go there. But the latency period is about 15 to 60 years. So people weren't exposed and then they were dying a couple of years later. It was taking a long while for any disease to show. There's around 4,000 deaths a year. That's still it's still predicted to increase. There's a significant proportion of work in the building allied trades. So these people are now disturbing asbestos. And they shouldn't be, but there's still works to go ahead without having a refurbishment demolition survey carried out. And even so, sometimes when people do surveys, it's never an exact science. People do miss things. So training the individuals to recognise what asbestos looks like is key for us as well. And it's important to limit all exposures. Oh yeah, there's a picture. So yeah, this is from Doll and Pito's work, but they were trying to, again, this sort of in the late 80s, so it was about at this stage. And they were trying to track asbestos disease, particularly mesothelioma, which asbestos disease is, try and track it with the amount we were importing over the years. So you can see the sort of curve square following. We were hoping to have exposures down to pretty much zero by about now, but as I say, there's still exposures out there, accidental exposures happening. Our peak use was between 1880 and 1999, when our last ban happened in 1999. There was millions of tons of asbestos were brought into the country, imported into the country during that period. 2.7 million tons of Crystalline, 500,000 tons of amosite, and then 50,000 tons of Crystalline. Mainly because there was a ban that came in, or sort of a voluntary ban that came in for blue asbestos in the mid-70s. So what have we done? Well, there's a prohibition of using of all asbestos in 1999. Crystalline was the last one to be banned. Most of the things were actually legislatively banned in 1986-87. We banned amosite, Crystalline, but then people started using the three letter types. So there was another piece of legislation needed in 1992. Control of asbestos regulations meant that since 2002, we've had to manage asbestos in non-domestic premises. The regulations also cover plans of work, licenses, notification schemes, operative training. Anybody who's working with asbestos should be trained properly, and medicals and base fit testing. And we're now moving on to sort of ground contamination, where it's been buried in the ground, and brownfield sites are being disturbed. Just a quick one. So that was what we're doing in the UK. This is a quick advertisement for myself. I'm a trustee of Workplace Health Without Borders, the UK branch. But I'm also sit on the Asbestos Working Committee. So there's a roadmap to international banning asbestos. You can have a chat with Nick or email Nick, and I'll get you the details for logging on to this in June 24th, 25th. There's just going to be a webinar. Again, our old friend Russia. Still, this is April 2024. Their asbestos industry paper, really saying how young people choose your asbestos, talking about how great it is, and then also a visit from delegate from Cambodia on the safe production and use of Crystalline. This is what we're trying to Workplace Health Without Borders is trying to get banned, but Russia is a bit of a devil. They threaten trade wars with people who try and ban importing asbestos from Russia. So they're still exporting it around the world. Guidance for you guys, occupational health people. So the main this is for doctors. So there's a HC medical series guidance notes. Medical series guidance note 13 is for GPs. So if anybody, a patient just went to the GP and they're worried they've been exposed to asbestos, that's gives them, the GP, some guidance. And MS31 is for appointed doctors, so how they supposed to react. But in most instances, the guidance is, what we tell people is that the small dose exposures is not going to significantly increase your risk of disease. No need for X-rays because asbestos fibers are so small you're not picking up on those. And this gives you some sort of idea of the risks. Not so obviously we know how bad smoking is, but yeah, and this is what we also tell people who work with asbestos not to smoke, really, because the exposure is combined. So the risk of a smoker against a non-smoker for getting lung cancer is 10 times. And the risk of an asbestos worker against a non-asbestos worker who's not smoking, the risk is 5 times more likely you would get lung cancer. Then the combined risk is 50 times more likely rather than 15. To put some science behind that for the advice that you're giving out. So Hodgson and Darnton are two health and safety exec epidemiologists, did a study. And they did find the risks. So I mentioned earlier that serpentines were less harmful than amphibole fibers. But yeah, they found this was representative. So blue asbestos was about 5 times more hazardous than brown asbestos, which in turn was 100 times more hazardous than Crystalline. But people do run away with. I've heard it said, white asbestos, that's the non-harmful, but still harmful, just not as harmful. So we can say that the risks are dependent on the amount. If we want to put a little bit of science behind that, we can work out. We can work out any expression of this, but we normally work out in 5 mil years because that's what studies normally carry out to. And then this is for Crystalline. So we worked out somebody's exposure. They were exposed, for half an hour or even a couple of days while they didn't know they were being exposed. We work out how many fibre mil years that is. This calculation that we can done. And again, there's a little bit of correction factor we put in for what age of exposure, but age of exposure to 30 to 35 years old of exposure, age at exposure, then these are the risks, and we sort of put up the control limits, or at the control limits where there'd be someone's working at the control limit. You'd expect 4 deaths per 1,000 exposed. It's a little bit different from the silica. So the silica is a weight thing. We draw silica onto filters or through a cyclone, and then that is measured on a weight-to-weight filter. Asbestos, we draw it through a mixed cellulose ester filter, collapse that filter onto a slide, and then we can read it. And that's what we look at when we're looking down the slide. We can see the fibers there. we're just doing countable fibres and respirable fibres. So we can't actually say, well, the more experience you get, the more likely you can say whether they're asbestos fibres or not. Nearly there, just a couple more slides. So the changes that have happened recently. The methodology for doing asbestos testing has not changed since I started. I think that was 34 years ago. With the same methodology is doing. The only thing that's possibly changing is this MPL test slide. So when you're calibrating your microscope to make sure that you can see down to fine enough fractions, we use an MPL test slide. We have to. There's a bands of these lines, and you normally have to count 5 bands along, unless, again, because the amount, it's a photographic image on glass, so the amount of failures they were getting, they sometimes allowed band 4 ones and made a mark that it was a band 4 slide to look at. There's a new technique for we're using modern semiconductor fabrication, which is going to make a superior replacement for this photographic image, but that's really not going to make a difference to the tests that we do. I mentioned the control limits and clearance indicators earlier. So 0.1% is the 0.1 fibre per mil concentration in the air is the control limit for all types of asbestos. Now that used to be different for the 2 types. 0.010 fibre per mil is the clearance indicator, and that's what we'd hand back school classrooms after a sort of removals over a weekend, and now children go back into school they'll go back into that classroom. There's still quite a lot of fibres in the air at that range, but because you've moved the source, the expectation is that the concentration will go down lower. So if you think about 0.01 fibres per mil, that pretty much times up to 10,000 fibres per cubic metre. So for pretty much the area under your desk, you allow 10,000 fibres and the air is still deemed clear. But as I say, that's only because the expected result is that the fibre concentration will go down over time. There was talk about bringing down the limit to what the background level is, which is 0.305 fibres per mil. But that wouldn't practically be able to do clearances in time and hand back areas. Thank you for listening.
Jason, thank you so much for this wonderful presentation.
Sorry if it was the wrong pitch or the wrong level, but
it was absolutely fantastic. I really, really enjoyed it.
Excellent.
Let's see if there is any questions here. Yes, no question at the moment. Any questions? You can type it for me to just discuss it with Jason, or if you want to directly ask Jason, I'm happy with that as well. Any questions? Okay, so I don't see any. Oh, there's one, I think here. Let's see. Yeah. Thank you, Jason. Very informative. Please, can you talk about how you test for silica? Do you mind expanding a bit more on this, please, Jason?
Yeah, as I say, so you've got a pre-weighed filter. It is just drawing air through a pre-weighed filter. So a known volume of air through a pre-weighed filter. Then you weigh the filter, and there's also a cyclone involved, so that spins out any heavy particles, and then you can weigh the filter.
Okay, great. And just, one question from my side, if you don't mind. Sometimes some very basic water in the workplace, basically, just to better manage the dust, could help a lot in managing the whole situation of exposure to dust and silica. What do you think about this? And is it going to be a sort of effective measure, especially in some low-income countries, say in some African countries or Middle East, or just where they don't have enough resources to better manage the situation by filters or things like that? Any strong evidence on that?
No, not really. You are right. We will sort of want to eliminate at source if we can, which is why they use LEVs. We did do there was a campaign a couple of years ago where the Workplace Health Without Borders did a sort of rubbish LEVs, but basically meant it so people could design LEV systems through things you'd find on a bit like a scrap heap challenge, so that third world, developing countries could use those, or possibly have those things to hand. But yeah, you are right. It is difficult, and even in this country, I mean, those photos I showed you earlier were taken from this country, and we're still brushing up, dry brushing things up, just because I think people just see it as too big a problem to be able to clean up for. I don't know what the answer is. There are ride-on sort of vacuum cleaners that people drive around with, collecting up the dust, but there's still a limit to what they can do.
Okay, great. Many thanks. One more question here. Great slides. Could you please explore more on clearance limit that available in last slide?
The clearance limit, sorry. Yes, I don't know what. Yeah, sorry. Is that Damien? Was it? No, Amit.
Yes.
Oh yeah, sorry. So yeah, there'll be when the removals happened, or sometimes just if there's been an asbestos incident, we'll do some background monitoring. If the removals happen, we'll do clearance monitoring. So that's a 4-stage process where we make sure visually that everything has been cleaned up, and then we're looking at the sort of microscopic fibres in the atmosphere. Again, you've got a pump. I'll go back a couple of slides. Somebody will run a pump. That has to be at least 480 litres of air drawn through there, so half a cubic metre of air drawn through the pump onto one of these filters. And at that point, we're pretty much measuring a density. So you take that filter, then as long as it's not been overwhelmed with dust particles, we collapse it down into this green onto a slide, and then put it under a phase contrast microscope where you've got sort of green filtered field, and then you count a number. So you can't count the whole of that filter area. So you count a number of these particles, which are 100 microns in diameter. So you've got a known area. You can work out a known density on the filter because you've counted a known area of the filter. I mean, in real terms, you probably counted maybe one of these squares, but you don't count the square. You randomly just randomize around there, doing 200 fields. Then you count a known area. Then you can divide the density by the volume of air you put through, and that gives you your fibres per milliliter.
Great, thank you, Jason. One more question here.
Let's spend half a day explaining that on a P403 or something.
Thank you so much. Yeah, thanks, Jason. What do you think are some of the reasons why we have not seen the expected reduction in asbestos death since it was finally banned in 1999?
Yeah, that is difficult, and it probably is just the latency period between exposure and then the onset of disease. That can be up to 60 years. So people who are exposed in the 60s and people who are exposed in the 80s still, you could expect them to be shown with diseases now if they're old enough. So it is a difficult one. People are exposed at schools, unwittingly known exposed in schools. I know a young person who's 27, a young girl at 27, died from mesothelioma from asbestos exposure she picked up in the classroom. So it's before 2002, before we sort of had that need to manage all asbestos in non-domestic premises. We've started surveying for it. Obviously, all the surveys weren't completed overnight, so maybe 2010 was then. And there's still people who probably, most people are doing what they're supposed to do. Local authorities are supposed to do what they're supposed to do, but you still probably got small shopkeepers who haven't had any surveys done. But it's that sort of exposure that we're trying to get to.
Great, thank you so much. One more question here. Okay. Do we know what proportion of kitchen fitters are using LEV or water spray when cutting engineered stone?
We don't. Well, I'm only talking personally to people. Somebody out there might know, but no. I mean, these are the new recent studies that are coming out, and this is the new recent burst around occupational hygiene is the fabricated engineered cutting stone. Just because of, I mean, you could put on tool extraction on that, so we saw before, but the LEB, just because it's pretty much in people's homes, you're not going to have LEB systems set up, because I think most of it is cut to size in people's homes and cutting sink units out and cutting, holes out for ovens and that sort of thing. So that sort of engineered that we can't get LEB on, but they can put obviously wet the process down, and we can do on tool extraction.
Great, thank you so much. One more question here. I wish more companies would embrace occupational hygiene measurement and monitoring, otherwise the published WEL means nothing. What do you think about this, Jason?
I agree with you. Yeah, more people should do monitoring so they can work out what their exposures are. Not that monitoring is the sort of be all and end all or anything. If you've got good housekeeping practices, you can work out, you can demonstrate that you don't need to do any monitoring, but monitoring is always a good fail-safe for demonstrating in the future that you weren't exposing people. And again, as I say, workplace exposure limits shouldn't be the limit we're sort of aiming towards. If it's a carcinogen, we should be aiming as low as far as reasonably practicable. So the workplace exposure limit is not really what we're aiming for. And again, unless we're testing everybody and they're all, testing 100% of your workforce and they're all below that workplace exposure limit, that's well and good. But because of people's different styles of approaching jobs, etc., and that bell curve, or that sort of logarithmic curve, we're looking at 10% of that workplace exposure limit.
Great, thank you so much. And Dr. Will Ponsovi has finally provided some helpful information here. There are 10 cases of advanced silicosis that have been identified at the Brompton due to exposure to engineered stone. I think this is an issue which is growing, unfortunately, and something should be done about this. But perhaps to address it properly, we may need a sort of, say, international surveillance system to have some information about this and to give us warning about these sorts of new issues happening. But thank you so much, Will. Very, very, very helpful. Any other information? Any other questions? No? Okay, great. Jason, it was an absolutely lovely presentation. Many, many thanks for your time and for this informative presentation. I'm very grateful. And thank you so much to all of our colleagues who kindly attended the webinar. Wishing you all a lovely, wonderful evening. All the best.